People say the universe began with a bang, as if there was a dark, empty space. Then boom, an explosion went off somewhere inside it. That picture feels natural. It fits how our brains work, but it's completely wrong. And the reason it's wrong tells you something profound about how nature actually behaves. Here's the paradox. If the Big Bang was an explosion, where did it explode? Into what space? And what was there before? Those questions sound reasonable, but they're already asking for things the universe doesn't provide. Nature isn't obligated to make sense to our everyday intuition. Imagine a loaf of raisin bread rising in the oven. As the dough expands, every raisin moves away from every other raisin. From any raisin's point of view, all the others are receding, but there is no special raisin at the center. No raisin can say, "This is where the expansion started." The expansion isn't happening at a point inside the bread. It's happening to the bread itself. Space is stretching. That's the first idea you have to swallow. The Big Bang wasn't an explosion in space. It was an expansion of space. When astronomers first began to realize this, they didn't start with philosophy. They started with observation. In the 1920s, Edwin Hubble noticed that distant galaxies are moving away from us, and the farther they are, the faster they recede. Light from those galaxies is stretched, shifted toward red. This wasn't because we were special. Every galaxy sees the same thing. Space itself is expanding between everything. Subscribe and like for more videos that explain what's really happening beneath the surface, because this is where common sense quietly breaks down. Now here's where people often jump to the wrong conclusion. If the universe is expanding now, then earlier it must have been smaller. True. Denser. Hotter. Also true. Run the clock backward far enough, and everything gets closer together. That's the Big Bang. Not a fireball detonating in space, but the universe itself in a much more compact, energetic state. For a while, physicists argued about this. Some preferred the steady state idea, where the universe always looked roughly the same, with new matter continuously forming as space expanded. It felt comforting, eternal, balanced, but nature doesn't care what feels comforting. The decisive clue came by accident. In 1965, two engineers were trying to eliminate a persistent hiss in a radio antenna. No matter where they pointed it, the noise remained. It wasn't coming from Earth. It wasn't coming from the sun. It was coming from everywhere. That hiss turned out to be the afterglow of a much hotter universe, the cosmic microwave background. The universe was once so hot that light and matter were locked together. When it cooled enough, light broke free, and that light is still washing over us today. Not from a direction. From all directions. Space remembers. This is important. The Big Bang is not something that happened at a place. It's something that happened to everything. Now, people say, fine, but that still means there was a beginning. A first moment. And here's where even physicists have to slow down and be honest. When we run our equations backward far enough, we hit a wall. Density goes infinite. Temperature goes infinite. Time seems to stop. That point is called a singularity. But a singularity doesn't mean this is what really happened. It means our equations have stopped working. Feynman was very clear about this kind of thing. When your math gives nonsense, it's not nature being mysterious. It's you pushing a tool past where it applies. General relativity works beautifully for stars, galaxies, expansion. But at extremely small scales, quantum effects dominate. And we don't yet have a complete theory that unites the two. So did the universe have a beginning? Maybe. Or maybe time itself is more subtle. Maybe asking before the Big Bang is like asking what is north of the North Pole. The question assumes a direction that doesn't exist. There's another clue hiding in plain sight: entropy. The universe began in a remarkably low entropy state, highly ordered, smooth, special. Since then, entropy has been increasing. That's why time has a direction. That's why stars burn, structures form, and eventually decay. The real mystery isn't why entropy increases. It's why it started so low. Some modern ideas suggest the Big Bang wasn't the absolute beginning, but a transition, a bounce, a phase change, a fluctuation in a deeper quantum reality. Not because it sounds cool, but because the laws we trust hint at it. Quantum mechanics allows fluctuations. Space itself may not be a static stage, but a dynamic participant. Here is the key insight. The Big Bang marks the limit of what we can currently reconstruct, not necessarily the birth of existence. It's the earliest chapter we can read with confidence, not the first page of the book. And this matters, because it changes how you see reality. The universe is not a machine that was switched on in some moment. It's a process. A story written in expansion, probability, and structure, emerging from simplicity. Time, space, matter, these are not separate ingredients mixed together. They arise together, obeying rules that don't consult human intuition. Feynman loved pointing out that nature is under no obligation to be obvious. Our brains evolved to throw spears and recognize faces, not to intuit spacetime. When we demand simple pictures, we usually get them wrong. But when we let experiments lead, even into uncomfortable territory, we get something better than certainty. We get understanding. So the Big Bang wasn't the beginning in the way people imagine. It wasn't a bang. It wasn't an explosion. And it may not have been the beginning at all. It was a boundary between what we know and what we're still learning.